All right, we're going to be looking at free fall motion today. This is the object that's going to be moving. Free fall motion is characterized by the object being released from rest. So that means when it's dropped, its initial speed will be 0. And also we're going to neglect air resistance. So we're not going to worry about air resistance, air friction as it falls down, which is a pretty good approximation because we have a relatively dense object. It's not going to be moving that fast. So what do we have here? We're going to power on our electromagnet. That's going to hold this up in place initially because there's some metal inside here. I'm going to power on my spark timer. We'll have these both powered on. I'm going to press magnet, and that's going to turn on the electromagnet, and so I should be able to suspend that here with the magnet. And the last step is there's a button that's called spark. I'm going to press spark and hold it down until the object reaches all the way to the bottom. And there's two things going to happen when I press spark. Number one, the electromagnet will be turned off, and so it's going to drop the object from rest. And number two, there's going to be a spark that this falling object, it's going to make a spark and make a mark on this paper 60 times per second as it falls. So what we'll have then is a record of where the object is every 60th of a second. Let's take a look at what that looks like here. So that's it. And now we can take a look. I'm just going to bring you closer here. Let's take a look at our spark paper. And we can see these dots that were made here every 60th of a second. Now, we're going to be working with the location of the dots every 30th of a second. So we're going to want to take the first one, skip one, take the next one, skip one, take the next one, etc.